Hello everyone, welcome to It's Electronic Technocrat. After a very grand success of the season number 1, we are here today recording the first video of our season number 2, and this video will be based on the simulation and interfacing of the I/O peripherals with the 8051 microcontroller. Like, we will be interfacing the LED with the 8051 microcontroller using a Proteus 7.7 or 7 Professional. So it's a very warm welcome to all our viewers, and a very thank you to everyone basically who has subscribed, liked, and also viewed our videos and also our channel. So that's a very grand success, and I hope this continues ahead as well. So without wasting any time, let's move on to our video. Basically, this aims actually to study the interfacing and simulation of I/O peripherals with the 8051 microcontroller. Now here I am just telling you how to simulate your circuit before building it on the breadboard. So I won't be going in detail about this 8051 microcontroller here, neither I will be explaining you the code of it. In the near future, when I will be just doing all those projects basically, then I will surely introduce you the 8051 microcontroller with its all pin diagrams. Let it be the program code, let it be the what we can say, any XYZ things inside this 8051 microcontroller will be explained to you when I will be doing the hardware techniques or the hardware projects. So Proteus 7.7 or 7 Professional, the link will be provided to you in the description below, so don't worry about it. And also the code as well and the procedure about how to do it will be provided to you in the link below. So let's start it. So the first step here is, first of all, we need to use the Kill Vision basically, and we have this Kill Vision here. How to download Kill Vision, we will be providing you the link as well, or you can watch my previous videos where I have shown how to download the Kill Vision 5 here. Alright, so I have already opened it, so I will open it now here. So how to start it? So first of all, I will go to project. Alright, I will select the new MuVision project here. So it will ask you to start it up with a file name. So I am doing here a project called as LED blinking. So I will be running here LED blink, and there is no extensions here, right? .h or .text or .c here right now, but we will be using those extensions in the further part. So let's save it. Here we have saved it. So now it is asking us to select a device for target. Alright, so in the search bar just type AT89C51. There we go. So instead of writing the whole name, we have got here the 8089C51. The description is given here below. Like, 8051 is fully static 24 MHz CMOS controller with a 32 I/O lines with 2 timers or counters, the 6 interrupts or priority levels, UART, 3-level program memory lock, and 4 KB flash memory with 128 bytes of on-chip RAM memory. This flash memory is basically the ROM memory, alright? So don't confuse yourself between the flash and the ROM. And this is the on-chip RAM memory, that is 128 bytes. Okay, so select this and we will state OK. And copy startup.a51 to project folder and add file to project. We will just press yes. Alright, so now you can see here on the left side we have this target, and in this target we have the source group. Okay, so before going on to this, we will first of all write our code basically. So we will go to file, then new. Here you're gonna be typing your code. Let it be in the C programming, let it be in the assembly programming, let it be in the C++ or any other kind of languages. You can type this code here. Alright, so I have already typed my code here. Basically I just need to copy paste this code here. So just copy and paste it here. So I have copied the code and pasted here. So before moving on to any other different things, so first of all we need to save this. So click save, and now we have to save this by an extension called as .c. Now you must be thinking, why am I using the .c? because this is a C programming, so basically I will be using .c convention. If this would have been an assembly programming, I would have used the extension called as .asm, or else it would have been a C++ programming. I would have been using .cpp. Alright, so it's clear why I am using the .c extension. Alright, so here we go, led.c. Alright, so now we are going to save this file. This is the folder I have made on the desktop called as 8051, where I have been saving this .c file. Okay, so saved. So our .c file is saved. The next step would be going into the source group, right click on the source group. Alright, then go to the add existing files to the source group. Alright, here you can see led.c, alright, which we have created just now. This is the extension, or the type here is C file. Alright, so we will select this and press add here. For double surety or double guarantee, we again press it and then we close it. Alright, so now we are actually ready basically to build it basically. So let's go to build this program. Building the program basically here is checking for the errors, and if there are no errors, then it's perfectly fine. If there are errors, it will tell you on which line the errors are. So here we are. This is the build option, so I am pressing this build here. So here we can see 0 errors and 0 warnings, so we are perfectly fine. That's what a coder wants, 0 errors, right? Absolutely. So let's move on again. So we have found no errors here basically. Alright, so now what we have to do is just go in the target window, just press the right click on this. We have options for target, select that options for target. Here you can see extal megahertz. This extal really means the crystal frequency here in megahertz. Alright, so we're gonna set this crystal frequency to the standard crystal frequency of 8051. We all know it, right? So we will just do it, 11.0592. Alright, we have done this. Then we have to go to the output tab, and here we have to check box. We have to check this box. If it is not been selected, like this, select it, so that we can create an hex file here. Alright, and nothing else we have to change, so just press OK. And let's go on to the Kill Vision now. We have to build a circuit now basically, so I am minimizing it. So I am going to open my ISIS Professional Proteus 7.7 version. Alright, so now without wasting any time, we will be start building our circuit. We have to build an LED attached to a 8051, and we have to show the LED is blinking, right? So for the components, we have to go here. You can see these two things. It's the P and it's the L. This is the library manager and this is the component list. Alright, so go onto the component list. I'm gonna type 8089C51 here. Okay, so here we have the first IC here. So we're gonna say select this here, and then we're going to press OK. Click here, and then we're gonna place this IC right in the middle, and then press escape. Alright, so we have this 8051 IC here. Alright, as you can see, this is naturally a 40-pin IC basically. Here we have the extal 1, the extal 2. This is the 2 pins where the crystal is being connected. Alright, so we won't go into further details here. So just moving on to the other things, we need to build a reset circuit and a crystal oscillator circuit as well. So first of all, we need to build a crystal circuit. So we need a crystal here, a quartz crystal. Select OK, press here, and we're gonna be selecting this. Alright, so I'm gonna rotate this here. Before rotating, I'm gonna do this, select here, just press escape, right click on this and rotate it to clockwise. Alright, so I've rotated a clockwise direction. So now I'm gonna start connecting the wires. Here we have the first wire being connected, and it's going down here. to this point. Alright, so here we go, another wire, and slowly going. Alright, so now we have to select the capacitor circuit. Alright, the capacitors. Just select the capacitor here, just press OK here, and we will get the capacitor here. Here we go, connect it here, and one more we will connect here, and just rotate this to clockwise directions basically. And now we're gonna get these wires to be connected here. Alright, so connect this one to here as well, and these all will be connected. Wait a minute, so we will have to get them grounded here. So first of all, we will be grounding them by using this ground button. There we go. So just connect these pins to ground. There we go. So we have connected this, we'll connect this to ground. Alright, so oscillation part is being done, so we will be going to connecting the LED now. Alright, so to connect the LED, we want LED. Alright, so here we go, it's component mode. We go to the components, we type LED here, and we have hundreds of LEDs here basically. So we don't know exactly which LED to take. You can take any LED, you can take this as well. This is the analog LED, or you can take this blue, green, and we have hundreds of LED here. So I'll be taking blue here. So let's take it out. We have this LED here been connected. Here we go, we connected this LED. So in the code itself, we have seen that the LED is connected to pin port number 2.0. Alright, so we have to connect the LED's anode or either the cathode to pin port number 2.0 of the 8051 microcontroller, and one will be connected to the VCC power supply. Alright, so we're gonna do the same thing here. So let's wire this up. We will be connecting these things here. So let's go on to connect our cathode of the LED to pin port number 2.0. So here we gonna take the wire here for the wiring part. Alright, so here we go. We take a wire from 2.0, we connect it to the cathode of the LED. Now we want the VCC power supply. Alright, so for the VCC power supply, we right click here anywhere on the screen, we go to the terminal part, and then we go on to the power. That's correct, so power. This will be connected here. So we have taken the plus 5 volts, and we will connect the anode of the LED to plus 5. So we are done with the connections. Just one thing is remaining here. To the capacitors, we need to give a value. So instead of giving 1000 micro, we will be giving them 33 picofarads each. Alright, the values can be put by your own choice. This is according to the microcontroller standards. So basically I'm putting all these values according to these microcontroller standards. Alright, I will be explaining you microcontroller 8051 microcontroller, so don't worry about it in the near future. So this is for just simulation about how to connect an LED to the microcontroller. Alright, so before building an actual circuit, you are ready with your software design, so that you can tell anyone that we have built a software design, and according to this I will be building my hardware circuit. Alright, so now we are ready to go on to the next step. The next step would be here right now. So the next step would be double click on this mu-c thing, and then we have this dialog box appearing in front of us. So just go to the program file here. Here we go, the program file. Just select the hex file that we generated right down there and just open it here. Alright, then press OK. So now you're completely ready to simulate this thing. Alright, so here we go. Here we have the start button to just start the play button, and here we go. So the LED started to blink. That's what I wanted to show you. This is the LED blinking project using 8051 microcontroller. First, we have simulated this project so that before testing it on the hardware, we can simulate this on the software basically. So according to this software, we can build our own circuit. So here we have the result is out there. The LED is blinking here. to show you a bit of a zoomness here. There we go, the LED is blinking here. So that's the result. And thank you for watching this video, and I'll be posting more and more about this Proteus as well, and we will be having some very different products after this. So bye bye and take care.